Yes. We're going to take this in English for all you guys, and we're happy to be here. I would just want to start off with reminding everyone that this is probably one of the most popular symbols and icons in the world in regards to strength and safety and protection, and making us all somewhat feel looked after and protected. It's the logo of the man of steel. And I believe that it's crucial for Swedish steel to become this symbol in an industry that is often vilified for being breakers of the environment and the nature, instead of celebrated for the positive impact that Swedish quality steel has in terms of regular, more low quality product. So the industry itself is sometimes plagued by three main issues. We need to really be good at driving home our talent acquisition. We need to communicate very clearly to customers and the world that Swedish steel is a move in the right direction for the environment and not in the wrong direction. And we need to solidify this vision and this knowledge into the brands of our Swedish companies. And the world itself, in parallel with this, is also plagued by one of the largest instances of simultaneous natural disasters that are occurring all in different geographies and really displacing huge amount of infrastructures to the cost of billions every year. And I think one of the issues in the industry itself is also that we are really bad at recycling the steel that actually reaches the consumer market. So we have one huge problem for the world, and we have one huge problem for the industry, and I think we have a solution that can address both those issues at the same time. So I think that our solution is just a simple connected steel instead of the earlier dumb one that can empower truly brilliant commercial models. So first and foremost, we can connect the steel in our cities in order to get a heat map of the infrastructure. So when disaster hit and infrastructure is broken, Swedish steel knows instantaneously what's wrong and where it's wrong. And also, by having simple positional data in our steel components, we can stop relying on consumers being generous in recycling their material, and we can start empowering them by creating incentives for them. But Mani here will talk more about the key part of the city.
Yes, so for a current example, imagine the horrible events in Puerto Rico, and the complete infrastructure is devastated from disasters, and basically nobody knows what went wrong. They don't know the weak points, they don't know how they're going to fix it, they don't know how to allocate the resources, and they don't know how to rebuild it in a sense to not let this happen again. So instead, imagine a scenario where everything is built in the smart steel, and as soon as the disaster hits, we can see a real-time map of the weak points. We can see where the disaster is hitting the worst, and we can also answer questions like, how do we rebuild this in the most optimal way? How can we build this in order to not make this happen again? And also on top of this, for each disaster, each earthquake, each hurricane, the algorithms that are making these suggestions will get smarter using AI and machine learning. And this will obviously benefit society, it will benefit the customers, it will benefit the shareholders, and it will put the company on the track to once again become the supermen and superwomen.
And on the topic of recycling, as Fabian mentioned, it's completely built on the kindness and willingness of people to contribute to a better environment. And as we all know, this hasn't been enough. And we believe that smart steel is what can bring recycling into the 21st century. Through partnering up with governments and organizations that work with recycling and being able to track steel objects of all sorts and form, we could create an incentive system that brings people into the next level of contributing to recycling, and thus putting SSAB and Sandvik in the absolute frontier of leading the recycling revolution.
Okay. So now that we've talked about the problems and the solution that we're aiming towards, how do we get from where we are now to being the men and women of steel that we ought to be? First, realize that it's a very collaborative effort. So we need to collaborate with all the people that are involved, the stakeholders, the customers, and also unify all points of our presence, be it our products, our markets, and people that we deal with normally. And then gather as much information as we need through pilot projects that we run, maybe running out a couple of intelligent steel products and seeing how much information we could gather and utilize through the information that we have to push this vision. Yeah. So steel is everywhere, and it's at the core of our civilization. Yeah. So we need to make use of this vast presence to hold up and save the world that we so do love. We need to move from where we are and be the men and women of steel. We need to be. Thank you.
Thank you.
Okay.
One question. I like the idea about making things more efficient in taking care of disasters. And you mentioned also that there's a way to build an optimal way of taking care of a disaster. How can you elaborate a little bit more on that? What do you mean?
Yeah, well, the basic idea would be that today, since all steel basically is completely stupid and dumb, so each data point would make, for example, rebuilding a building easier. If we can see like where were the breakpoints, where were the weaknesses, was it? You could also put like metadata from geographical metadata to see if this was by the coast, for example. Maybe we need to do these adjustments in rebuilding this building. So I guess the main user case would be in rebuilding the buildings based on the data that was allocated from the disasters.
My question is, how do you reach critical mass in terms of adoption of the system? Because what you're describing would be a fantastic solution if it's wireless spread. But if it's not wireless spread, it doesn't make that much sense to just have the data point if it's not really more comprehensive. So how do you actually get the wide adoption and a critical mass for the usage of the system?
I think one of the key issues is that by focusing on a quite simple technology, I mean, we're only really talking about the geographical positioning of components and some level of internal structural data that is feasible to gather. I think the main thing would be to make it at an affordable price point so that you could roll it out without needing to increase price points.
Okay. I agree with you. This is an intriguing idea. During your work, did you have any other ideas that were wild and crazy that you discarded due to that?
Yeah, we actually talked about several key ideas.
Yeah.
We talked about having the exterior material in transportation vehicles extract geographical data, like ships getting ocean data or aircrafts getting ozone layer data and stuff like that. Also very environmental friendly to communicate the issue that Swedish Steel cares about the environment. Then we had self-replicating and self-building steel. We imagined a vision where you could like roll out steel that is intelligently rebuilding itself or remodeling when it's stressed in order to continuously address like pain points. And those are all beautiful visions, but I think one of the key messages is that it needs to actually be feasible, and we need to start communicating this message quickly. I mean, it would, again, be beautiful. Yeah. Thank you.
Okay.